So I want to go over some of the basic concepts in Chapter 5, which is about the t-test and the Mann Whitney U test. There's a lot more details in your text, but I wanted to hit some of the high points for this chapter. So in using a t-test or a Mann Whitney U test, we're going to be testing differences between two unrelated groups. So an intervention group and a non-matched comparison group. We might be looking at differences between males and females. We might be looking at groups with and without a certain medical condition. So if we're looking at differences between these groups, then you would use this type of test. What we do with this test is it's a test of testing mean and median differences. And so an independent t-test or a Mann Whitney U test are the two different types of tests we're going to cover. So when we talk about what type of variables we are using, our grouping variable might be nominal and dichotomous. So it would need to have two different categories, and this would define the two groups being compared. It's usually the independent variable that we are grouping this way, and so we may be looking at gender or immunization status. So if we were looking at those who'd been immunized and those who hadn't been immunized, that's a nominal variable and it has two different categories. And so that is what we would consider, and that would be an independent variable if we were looking at an outcome variable, let's say of maybe side effects or something like that. And so so that's how we would, usually the independent variable is this grouping variable that we're dealing with. I would say be careful about defining gender in a dichotomous way. Generally, that is no longer a dichotomous variable. We're looking at that depending on how you're defining gender. There may be more than two choices. If we're looking at the dependent variable, and so the characteristic of interest variable, so this is the outcome variable. It's generally interval or ratio, and it's usually the dependent variable. And some examples are length of stay in the hospital, age, weight. So maybe we look at something that whether those who had been immunized or those who hadn't been immunized and how long they had to stay in the hospital for a certain medical condition. So generally, this is your dependent variable, so your outcome variable. So here's a typical research question that you would use a t-test or a Mann Whitney U test on. On average, will male dieters lose more weight over a 3-month period than female dieters? So our grouping variable, which is the independent variable, is gender, and they have it defined just as male and female. And then the characteristic of interest, which we call the dependent variable, would be weight loss in pounds over a 3-month period. So the statistical tests that we can use are the independent t-test. And so again, this compares the means of two unrelated groups. It's a parametric test. So that means we assume that the data is normally distributed. And we talked a little bit about that when we talked about descriptive statistics and normal distribution. It reports the means of each group and the standard deviation of each group. The Mann Whitney U test is a similar type of test. So these are tests are kind of paired together for a reason. It compares the distribution of the values in two unrelated groups. It's a non-parametric test. So if your data is not normally distributed, you could use the Mann Whitney U test. It reports the median of each group instead of the mean, and it reports the interquartile range of each group. So a question to think about, the variable height in inches is a clear example of which of the following types of variable: a grouping variable, an independent variable, a dependent variable, or characteristic of interest. So D, characteristic of interest. So height in inches is interval or ratio, and it could be a dependent or an independent variable depending on the research question. It's most likely, if we think about maybe a dependent variable, depending on what you're looking at, but it also could be an independent variable. So how we start in computing the independent t-test is that if we sort of use this example that they have provided, we are looking at a study of 17 male and 15 female dieters, and we create a hypothesis. So remember, the null hypothesis states that there will be no difference. So for this example, it would be there will be no difference in weight loss between male dieters and female dieters. And then the hypothesis stems from the research question that was from earlier: do male dieters lose more weight than female dieters? So you're going to start by stating the null hypothesis, which is that there'll be no difference. And then the alternative hypothesis: there will be a significant difference in weight loss between male dieters and female dieters. You'll notice that this hypothesis is non-directional, and so we aren't saying that one will lose more or less, but that there just will be a difference between the amount of weight lost. The next step is to define the alpha level, and so our alpha level will be defined as p less than or equal to 0.05. This is a common alpha level for healthcare research. If you're looking for something more specific, it may be 0.005 or even more specific, 0.001. But for most of our examples, we'll use p being less than or equal to 0.05. The critical value. So if you're sort of calculating this all by hand, you would look up the critical value in the T table. Just remember that that I'm not requiring that you calculate these by hand. So this becomes a little less important because your SPSS software will actually calculate this for you. But if you were doing it by hand, you would find that the critical values were plus or minus 2.042. And so when you run the test by hand, if it's greater than 2.042 or smaller than negative 2.042, you would reject the null. So ensure that data meet the assumptions. So make sure that your grouping variable is dichotomous, that men and women in the study constitute an independent random sample, that the weight loss data are normally distributed. So you would want to look to see in your stem and leaf plot and in your histograms, and then weight loss data are of ratio measurement scale. So those are sort of the assumptions that this data would need to meet to use a t-test or a Mann Whitney U test, or a t-test, sorry. This is just about the t-test. So if you do a stem and leaf plot, you can see the type of data that we have. Another way you could look at this would also be in a histogram. You compute the mean and standard deviation for each group. And so when you're looking at the mean weight loss over 3 months, you can see that women have 12.3 pounds, men have 18.59 pounds, and then the mean overall is 15.56. And then you have your standard deviation here. SPSS will calculate all this for you, so you don't need to calculate this by hand. So then you're going to compute the independent t-test. I'm not going to review this, but this is basically the formula that would be used in order to calculate this. We will do this in SPSS, so you will not be doing this by hand for your homework assignment. You would then determine statistical significance and state a conclusion. And so in this example, the computed t-test comes out to 3.16, which is bigger than the critical value of 2.042. And we'll basically then conclude that the difference in mean weight loss between males and females is statistically significant. So if you were to summarize this, if you were looking to summarize the results that you got, something written like this would be an appropriate way to demonstrate this in writing as you were writing up, let's say, like a results section. So men lost an average of 18.59 pounds, and then generally we put in the standard deviation. Sometimes you'll see standard deviation listed by a plus with a minus, and so it could be also listed that way. And women lost an average of 12.13 pounds with a standard deviation of 5.46. This is a statistically significant difference at p less than or equal to 0.05 by the independent t-test. So that may be how you write up a result for an independent t-test. So another question to consider, do adults who are immunized against the flu lose fewer days at work than those who are not immunized? So which of the following would be the grouping variable? And that's immunization status. So you're either immunized or not immunized, and that defines the two different groups. We will go into a little more depth on using SPSS in the next presentation, but I wanted to just give you a quick overview of some of the important concepts of the t-test and the Mann Whitney U test.